This training video will illustrate two types of special ditches. One, a ditch at the base of fill. Another, a ditch that follows a special profile, a defined profile, and therefore might extend to a variable distance from center line. And thirdly, working in the DGN environment. Let's move over to our drawing, which is a DGN. Carlson 2018 can work in both DGN and DWG environments. So if you select here in the DGN environment, hit the delete key, just like you're in MicroStation, it deletes and Control-Z brings it back. The commands are Carlson style, but you're working native DGN. This is a breakthrough feature of Carlson 2018. Now we have a RoadNet file defined, RoadNet functions within the DGN environment. And if we double click, we go into the editor and we will study the template first. When we go to the template, we'll notice three things we'll focus on. The fill icon governs how we do fill. Notice we have three fill conditions based on depth and smooth slope transitions, meaning that perhaps if we had a depth of 7 feet, it might be 3.5 to 1. At the base of the fill, we've called for a ditch to be forced up to a fill depth of 40 feet. We've even turned on use guardrail over 10 feet of depth, though in our case here, none of the fills over 10 feet, so it's somewhat academic. Now, let's move over to the super icon, and we have a parametrically defined pivot point for the high side super on the surface at the edge of pavement plus 4 feet. So edge of pavement can move in and out. That template ID can expand and contract. But 4 feet beyond it, halfway into the shoulder, we will pivot for super, never to exceed 7% algebraic difference. You'll see this kick in. Notice that the shoulder is 8 feet. Lastly, we'll look at our subgrade. You can have multiple subgrades. We just have one specified at a 14-inch depth from surface, but it has a fixed 2% slope. Therefore, it will thin in the shoulder as the shoulder comes down at 4%. As it seeks daylight left and right in the cut and fill. You don't have to enter anything down here unless it's extremely specialized in the low and high side, because it will follow normal crown and super elevation with a uniform slope under the surface grade by default. So now we're ready to exit here, and we don't need to save any changes. We've made no changes. We have a super elevation and a special template ditch profile that if we edit it, we'll notice that it applies from station 50 to 250 following a certain alignment, vertical alignment. And what this means is we can just cancel out and don't have to save anything. It means that beyond 250, it'll be the normal template definition of what happens in the ditch. Okay, we were going to output an existing and final cross-section file, so let's run it out. Quickly runs out here and recalculates. And now we're going to go to Input Edit Section, take a quick look at two of the sections. We'll bring in the road final surface and reference the existing grade. And we'll go to 150 first. And we'll notice there's the ditch chasing that profile elevation at the current slope. There's two methods: steepen to the normal offset of the ditch to that profile grade, or simply extend to the profile grade, which it is doing here. There's our cut at base of fill. Let's move on to, and also notice before we move on that the right side high side super is going to 6% up to the point I just clicked, highlighted above, and then with the 7% algebraic difference in play, going over to negative 0.95% slope. So that is active. Lastly, we'll look at station 500, which is beyond the special ditch region, and therefore it uses the normal cut slope, and you can see it over here at 3 to 1 over a distance of 6 feet, dropping down 2 feet, and the ditch at base of fill.